Class, let's read our next question, which is question number 81. Which among the following solutions has highest freezing point? The given options are NaCl 0.1 molal, K2SO4 0.1 molal, urea 0.1 molal, and the last option is MgCl2 0.1 molal. Class, first of all, we need to know the Van 't Hoff factor, that is a value of I for the given four options. For NaCl, the value of I is 2. For K2SO4, the value of I is equal to 3. For urea, the value of I is 1. And for MgCl2, the value of I is 3. So urea has least number of particles. Therefore, urea will have the highest freezing point, as the solute which have the least number of particles will have the highest freezing point. Therefore, the correct answer is option number 3. Let's move to our next question, class. Which colligative property is the best method for the determination of molar masses of macromolecules? Class, this question is again from colligative properties and one of the most frequently asked questions. We have to analyze that which colligative property is used for the determination of molar masses of macromolecules. The first option is elevation in boiling point. The next option is depression in freezing point. The next is relative lowering of vapor pressure. And the last option is osmotic pressure. In this question, the correct answer is osmotic pressure, because osmotic pressure is the only colligative property which shows high value for even a dilute solution. Therefore, the correct answer is option number 4. Class, let's move to our next question, which is question number 83. The vapor pressure of acetone at a certain temperature is 480 mm of Hg. A non-volatile, non-electrolyte solid weighing 0.2 gram, when added to 5.8 gram of acetone, the vapor pressure of the solution now becomes 470 mm of Hg. We have to calculate the molar mass of the solute. The given options are 170 gram per mole, the next is 94 gram per mole, the next is 188 gram per mole, and the last is 72 gram per mole. Class, this is again a very important question, belongs from colligative properties, class 12, chapter number 2nd. This is the first colligative property, that is relative lowering of vapor pressure. The formula for this is P0 minus P upon P0, which is ultimately equals to number of moles of the component 2, number of moles of component second plus number of moles of component first. The P0 has a value of 480. The vapor pressure of the solution becomes 470 upon 480. The number of moles of second component is unknown. The number of moles of first component is 0.1. So, the value of number of moles of second component is 1 upon 470. The mass of the second component is already given, which is 0.2. So, we can calculate the molar mass of the second component or the solute is equal to 470 multiplied by 0.2, which is ultimately equals to 94 grams. So, the correct answer is option number 2. Class, let's move to our next question, which is question number 84. Let's read the question first. A solution has 2:3 mole ratio of hexane and benzene. If vapor pressure of hexane and benzene at 25 degrees Celsius are 360 and 300 mm of Hg respectively, then mole fraction of hexane in the vapor phase would be, the given options are 0.44, 0.55, 0.35 and 0.72. For calculating the mole fraction of any component in the vapor phase, the formula used is the vapor pressure upon the total pressure. To calculate the total pressure, the formula used is P1 naught x1 plus P2 naught x2. the values are given. The value of P1 naught is 360 multiplied by the mole fraction of first component is 2 total, that is 5. So the value of x1 is 2 upon 5 plus the value of P naught 2, second component is 300 multiplied by x2 has a value of 3 upon 5, which ultimately becomes equal to 324. So we can calculate the value of y, which is equal to 360 multiplied by 2 upon 5 upon 324, which becomes equal to 0.44. So the correct answer is option number 1. Class, let's move to the next question, which is question number 85. Let's read the question, class. Van 't Hoff factor of 0.1 molar aqueous solution of Al2SO4 whole thrice, that is aluminium sulfate, which undergoes 80% dissociation. The given options are 3.6, 3.2, 4.2 and 4.8. Class, let's consider the dissociation of aluminium sulfate Al2SO4 whole thrice. On dissociation gives 2 aluminium 3 plus 3 SO4 2 minus. Let's take number of moles of aluminium sulfate initially as 1. So number of moles of aluminium 3 plus and sulfate ions will be 0 initially. After dissociation, the number of moles of aluminium sulfate left is 1 minus 0.8 and the number of moles of aluminium 3 plus formed is 2 into 0.8 and sulfate is 3 into 0.8. So the value of I, that is Van 't Hoff factor, will become 1 minus 0.8 plus 5 into 0.8, which ultimately becomes equal to 4.2. So the correct answer is option number 3rd. Class, let's move to our next question,